Hello, welcome to this 22nd topic in this course. We're looking at handling data in algorithms. That's the official title from the specification. Not a great title, to be honest. It doesn't really describe what we're doing. We're looking really at some theory behind some key points in programming, such as variables, constants, data types, and arrays specifically. So let's get straight into it. First of all, let's have a look at variables and constants. One of the first things you've done when you code is talking about variables and using variables. They're really key in so many ways in computer science. They really are the foundation of coding. So looking from a theory kind of point of view, the technical term is they're both identifiers, meaning that they're like containers for values. So they're called identifiers mainly because they're assigned with values which can be referenced by the programmer with the name given. That's where identifier comes from. The name is used to be as a reference point to these values that are contained within them, that are assigned to the identifier. So technically the identifier is sort of the name given, but we sort of call them identifiers. You may not need to know this, I'm just trying to be as complete as possible. And technically constants are just types of variable, just with special properties, but we'll look at that in more detail in a second. So here it's really good to start looking at code with kind of like an analytical type view. So in English you might look at a sentence and decompose it into different types of words with connotations, etc. In computer science you're really trying to decompose code and looking at exactly what it's doing. You may understand what it's doing, but it's good to get in the habit of explaining it in as much detail as possible. So here what's happening, we've got the value 10, this integer, being assigned to the variable var, I've called it here, and that's the identifier in this variable. And then we've got the function print, and we've got our parameter here for a function, and var is the parameter. It's contained within the parameter which gets passed to the subroutine. I mean, in fact, the actual argument, the actual bit of data that's passed to the function print is 10 because it's the value of var. So I'm going to maybe a bit too much detail here, but like I said, it's good to get in the habit of sort of talking like this, especially in your exam. Sort of describe it in a lot of detail. Sorry, not in your exam, in controlled assessment, but maybe not in so much detail in your exam. But regardless, it's good to know, especially. So also, variables and constants can be declared with certain properties. So declaration sort of implies that it's done right at the start, and this often happens. I mean, you can start off your code with just assigning it, but you can also declare it with certain properties, and this is maybe more obvious and slightly in different programming languages compared to Python, so I should mention I'm using Python here, as I've done in all the other videos, but it's not that clear cut. But what we're doing in this little bit of code, we're declaring this value, this variable x, as a string, and a string is a type of data type, as we'll look at next. But what this means is it means that instead of an integer being assigned to this variable x, a string's assigned instead, which we've declared. So that's just a bit more theory there. But if you want to, I know some people like to really define things. So here's quite a definition for variables. So variables are structures that hold data. The value assigned is held until it's changed or the program completes, and therefore, this is the key bit, a variable's value can be changed during a program's execution. So here we've got a bit of code that just shows this change happening. We've got a variable assigned with 10, and afterwards I change it from 10 to a string, and clearly it shows that variables have the ability to change during execution, which is key because constants, as the name suggests, they don't change. They're the same with variables. I mentioned that they're sort of like a type of variable, but regardless, they're structures that hold data. The value assigned is held until the program completes, not until it's changed, because it can't be changed. As soon as it's assigned or declared, it doesn't change through the execution. So in Python, like I said, I could have changed to another language here, but I've used Python, and I know a lot of people use Python in this GCSE, so I'm keeping with that. But an example in another area is the first one I thought of was in maths. So we've got a quadratic here, or a polynomial, whatever you want to call it. And in red, we've got our constants in this equation. So we've got a, b, and c, and often this is 1, this is maybe 5, or yeah, it doesn't actually matter. But this will change whatever. Remember, we've got our variables x here, and often instead of y you see f of x in maths, especially as you progress to sort of A-level maths. You see f of x instead of y, and this is what we're saying, it's a function of x. So we pass a value of x, say 5, into this function, and we replace these variables with that value. And that's just an example of in everyday life using variables and constants. I just thought I would add that in there. Anyway, I mentioned we're going to talk about data types. So this is quite an obviously absolutely fundamental idea, but it's slightly difficult to explain. But really what data types are, they're classifications to distinguish between types of data. And one of the reasons that's quite difficult to explain is because it's difficult to define them without using the actual words. But I'm sure you'll get away with it if they do ask you to define it, because I can't think of any other way to sort of explain it. So the reason we have data types is that there's lots of forms of data. There's words, there's letters, individual letters, there's numbers, and a computer needs to be able to distinguish between these types of data in order to know what operations can be performed on what. This actually ties in fairly nicely with a video I did on instructions in terms of like bit patterns, which I did a while ago, which I'd recommend you watch anyway, but it maybe is quite good to consolidate this. But we've got to look at 5 main types of data type. I mean, it's probably the 5 ones you actually ever use. First of which is an integer. And an integer, you hopefully would know from maths, is simply a whole number. So an example is 5, 10, 30, a whole number. So 30.5 is not an integer, it's not a whole number. A boolean data type is one of 2 values. So usually it's true or false. We looked at a video on Boolean logic at the start, it was like the second video, and yeah, a Boolean is either false or true, and false is usually represented by the binary value 0 and true by 1. A real, also known as a float, the example would want you to know of it as a real, not a float. So float, it's called float because of floating point numbers, which is basically just a decimal or fractional number, but you want to call it real. So an example is 8.2 half, 2/3, that's an example of a real. A character is just a single unit of information, so 5, even like a symbol, like the percentage symbol, that's a character. And often this is put in single quotes, like in Python it's got single quotes. And a string is just a sequence of these characters, like hello world, that's probably one of the first things you ever typed in code. It's usually what they teach you first, and that's again usually has 2 apostrophes. So the reason why we use data types is that a computer needs to know, as I mentioned, what operations can be performed on what. It prevents distinguishing between all these data types, prevents serious errors occurring, like a computer completely crashing, because it tries to perform an operation that isn't possible. So in real life, you wouldn't be able to, there's no logical way to divide a letter by a number. It just doesn't make sense, and so a computer obviously can't do that. It's not programmed to it. If we can't do it as intelligent humans, a computer can't do it. And so it will only divide with integers and or reals. So it only can divide by numbers basically. And what this means is that you need to distinguish between the 2. So here I've just got an example. So I'm doing exactly what I just said. I'm dividing a integer here by a string, and clearly we get an error here. And I don't know exactly how Python IDE works, I don't know the code behind it, but again, looking at it from a computer science perspective, we analyse what this is saying. I mean, the next video is actually on errors, but regardless. So what it's saying here, basically, as we would expect, it's got an unsupported operand type. In the bit pattern video, in the instruction video, we looked at operands and operators. The operand is the data passed, the data in part of an instruction. So what it's saying is it's got an issue with the data given to it. It doesn't mind this divide, this slash, doesn't mind the divide, that's the operator, but it doesn't like the operands here, the data. And clearly that's true because it doesn't like the fact that you're dividing an integer by a string. And obviously it seems like there's been sort of catchment in Python that stops it being run properly, otherwise you'd encounter a serious error. So that's why data types are used. Hopefully that makes sense. It's quite difficult for me to explain, but once you understand it, it's not that difficult to really think about. So finally, we're going to look at different types of operators, different ways to sort of write expressions or equations in programming languages. There's 3 main types: Boolean, arithmetic, and comparison, and they're sort of written slightly differently in different languages. These are just examples, and there's a few more as well. So yeah, just do a couple of examples here, I suppose. So here we're using a Boolean operator, or in Python it's written lowercase, doesn't really matter. So what it's saying here, if number 1, variable number 1 or number 2 is equal, so we're also using comparison operator here. It prints pick a new number. So just it's either this variable or this number equals 0, and it's comparing this to 0. Yeah. So here we've got a function, an addition function, and again I've got our parameters here, and it's using a arithmetic operator plus here, quite simply. And finally, we've got an example of a Boolean data type being given back to the program, where what it's doing is comparing 5 to 10, and clearly 5 is not equal to 10, and so we get false back from the program. Okay, sorry, I think I said finally, but no, finally what we want to do is look at arrays. So an array is an ordered arrangement of data elements, and data elements are just data values or variables, so you can use both. And typical arrays are homogeneous. Hopefully I've said that right, but you won't need to know what that means. Well, you won't need to use that term, but what that means is it means that the elements are of the same data type. Typically, arrays consist of the same data type, so all strings, all integers, all reals, etc. Lists on the surface, ostensibly, are the same, but typically they're heterogeneous, however you say that, meaning that they can be composed of different data types. And in Python, actually, lists replace arrays. There aren't any arrays in Python unless you use some modules, but regardless, but on the surface they are the same. The way they actually work slightly differently, but that's definitely not a GCSE level topic. So the elements in arrays are referenced by their location. So it's basically just a group of elements stored together instead of separately, and are referenced by the location in a process called indexing. And here you might think perhaps that we would get football back instead of cricket here in this little sport array, because this is the first element in this array, but actually this is an example of zero indexing. So Python is one of the many languages that use zero indexing, which means you start counting from 0. So this position is 0, this is the first position, and this is the second position with zero indexing, which is why you get cricket back instead of football. And the above example is an example of a one-directional array, and this just means that it's stored in one direction, one horizontal direction, and so you only use one number to index it. You don't need to know about multi-dimensional or two-dimensional arrays, but basically they store data in more than one direction. So instead of just horizontal like this, they store them vertically as well, which means you have two numbers to index it instead. It's sort of like a list within a list, or an array within an array, but that's beyond your spec, so you don't need to know. Anyway, hopefully that video was useful. Hopefully I explained things okay. It's slightly difficult to explain some of this stuff, but anyway, next up is the last video, and we're looking at testing, so hopefully you'll join me for that.